Hello friends, I welcome you in lecture number 5 on normal distribution. In this lecture we are going to discuss alternate standard normal distribution table. In previous lectures we have discussed the probabilities using cumulative normal probability table, in which we are using this type of table. In that cumulative probability tables we are given the areas to the left of specified values of z. That means we are given the probabilities that capital Z is less than or equal to some specified value of z. So that table is known as cumulative normal probability table, in which we are given the areas to the left of specified value of z. We have some another standard normal distribution table, in which instead of this type of areas we are given the areas between z equal to 0 and some specified values of z. That means we are given this area from z equal to 0 to some specified value of z. So in this lecture we are going to discuss that how to use that alternate standard normal distribution table to calculate areas from 0 to z as well as from another areas. So we understand with the help of examples. Before that we have a look at the table which gives us the areas from 0 to z. So you can see here we have, this is the area from z equal to 0 to some specified value of z. So this area is nothing but probability that capital Z lies between 0 and z. So in this table the entries are nothing but this type of areas from 0 to specified value of z. For example, if I want to find out the probability that 0 less than z less than 2.34, that means I want to find out the area from z equal to 0 to z equal to 2.34. So I will look for 2.3 below this z values. So we can see here we have 2.3, but we have to go up to 2.34. So as we have discussed, 2.3 can be written as 2.3 plus 0.04. So you can see here we have these values 0.00, 0.01, 0.02, 0.03 and 0.04. So for 2.34 we have to concentrate here on 2.3, and here we have to concentrate below this entry 0.04, and these entries are starting from 0.00. So from this I have to search for 2.3 and parallelly 0.04. So this is for 0.00, this is for 0.01, 0.02, 0.03 and this is for 0.04. So required area is 0.4904. So in this way we can use this standard table. Before that we write this value is 0.4904. So 0.4904 is the area under the standard normal curve between z equal to 0 and z equal to 2.34. So this table values are nothing but areas between z equal to 0 and z equal to some specified value. So we discuss some examples how to calculate this type of areas, or how to use these areas to calculate another type of areas. So first example is find the area under the standard normal curve between z equal to 0 and z equal to 1. So you can see I have sketched the required area. This required area is nothing but probability that z lies between 0 and 1. So it is in standard form. It is the area between z equal to 0 and z equal to 1. So we have to concentrate for z equal to 1 in the table. So here we have z equal to 1, and because we have z equal to 1, that we can write as 1 plus 0.00. So we search here below this and parallel to this. So the required area is 0.3413. So which we write here, area between z equal to 0 and z equal to 1, that is nothing but probability that z lies between 0 and 1, and it is 0.3413 from the table. Another example, find the area under the standard normal curve from z equal to minus 2.34 to z equal to 0. So we are asked to find out this area shaded by red lines, but we know that this graph is symmetric. So from the symmetry of the graph we can see this area from minus 2.34 to 0 and the area from 0 to 2.34, both are equal. So probability that z lies from minus 2.34 to 0 is nothing but probability that z lies between 0 to 2.34 by the symmetry of normal curve. So these two areas are equal. So by the symmetry of normal curve we can write that probability that minus 2.34 less than z less than 0 is nothing but probability that z lies between 0 to 2.34, and we are having this type of table values. So in the table we will concentrate on 2.34. So we look for 2.3 below this z values, and we have already find out this value, probability that z lies between 0 and 2.34 is nothing but 0.4904 as I discussed. So we substitute that value here, 0.4904. So in this way we can write for any z value probability that minus z less than capital Z less than 0. This is nothing but probability that 0 less than capital Z less than small z by the symmetry of normal curve. So we are using that property of normal curve here, symmetry property. We can make this remark. You can see this two shaded area here, area by these blue lines, that is area to the left of z equal to 0, and this area is to the right of z equal to 0. So that is nothing but probability from 0 to infinity, and this area to the left of z equal to 0 is nothing but probability from minus infinity to 0. And as we know that normal curve is symmetric, these two areas are equal. Now we know that the total area under the standard normal curve is 1. So these both areas must be equal to 1/2, that is 0.5. So area to the left of z equal to 0 is 0.5, and area to the right of z equal to 0 is also 0.5 by the symmetry of normal curve. So we can write in this way, by the symmetry of normal curve, probability that minus infinity less than z less than 0 is nothing but probability that 0 less than z less than infinity. And since the total area under the normal curve is 1, these two areas must be equal to 1/2, that is 0.5. Next example is find the area under the standard normal curve from z equal to 1 to z equal to 2.70. So we are asked to find out this shaded area from z equal to 1 to z equal to 2.70. So if you observe, we are having this type of table values, probability that z lies between 0 to z. So we have to convert this probability in terms of this probability. So if we observe area from 1 to 2.70, this area can be written as difference of area from 0 to 2.70 and area from 0 to 1. First I consider area from 0 to 2.70, that is this part, but I require area between 1 and 2.70, so I have to subtract this area from this total area. So area up to 2.70, area between 0 to 2.70 minus area between 0 to 1 is nothing but area between z equal to 1 and 2.70. So here I have written probability that z lies between 1 and 2.70 is nothing but probability from z equal to 0 to 2.70, but I require this shaded area only, so I have to subtract area between z equal to 0 and z equal to 1. Now this we can decide from the table. First we look for z equal to 2.70. So I have to search for 2.7. So here I have 2.7 and I have to search for 2.70, that is 2.7 plus 0.00. So this is our required entry, 0.4965. So that we have written here. And area from z equal to 0 to z equal to 1. So I have to look for z equal to 1. We have already discussed. It is 0.3413. So that we substitute here and the difference is 0.1552. That means area from z equal to 1 to 2.70 is 0.1552. Next example. Find the area under the standard normal curve to the left of z equal to minus 0.94. That means we are asked to find the probability that capital Z is less than minus 0.94. So you can see if this is 0.94, this is minus 0.94, and area to the left of minus 0.94 is nothing but probability that Z is strictly less than minus 0.94. Now if you observe, then from the symmetry of this normal curve we can see that this area is nothing but this area. Both the areas are same. Area to the left of minus 0.94 is same as area to the right of 0.94. That is probability that Z is bigger than 0.94. These two are same. So first we write by the symmetry of normal curve, area to the left of minus 0.94 is nothing but area to the right of 0.94. So if we want to find out this area, it is sufficient to find out this area because both areas are equal. So value of this area is equal to this area. So we try to find out this area. Now if you observe, area to the left of Z equal to 0, area to the left of Z equal to 0 is 0.5. So this total area under the standard normal curve to the right of z equal to 0 is 0.5. Okay, we have made the remark that area to the left of z equal to 0 and area to the right of z equal to 0 are equal and their equal value is 0.5. So here area to the right of z equal to 0 is 0.5, means this total area is 0.5, but we are interested in this area to the right of 0.94. so we have to subtract this area from z equal to 0 to 0.94 from 0.5. so probability that z is bigger than 0.94 is nothing but 0.5 minus area between z equal to 0 to 0.94. Again I repeat, area to the right of z equal to 0 is 0.5. We are interested in this area to the right of 0.94. So area to the right of 0.94 is nothing but 0.5, that is area to the right of z equal to 0. So 0.5 minus area between z equal to 0 and 0.94. And we have this type of areas in the table. So we search for 0.94 in the normal probability table. So 0.94 means I have to concentrate on 0.9 and then I have to go up to 0.04. So this is for 0, this is for 1, 0.02, 0.03 and 0.04, that is 0.3264. so which I substitute here and the difference is 0.1736. so in this way, if we have we are not having areas which are given in terms of tables, then using the symmetry of this normal curve we are able to convert required area in terms of known areas which are given in the table. Next example, find the area from z equal to -3 to z equal to 2.65. so you can see this rough sketch. This is z equal to 0. Suppose this distance is 3, so this is z equal to -3, and suppose this is 2.65. so we are interested in the area from z equal to -3 to z equal to 2.65. that means we require this both the areas, area between -3 to 0 plus area between 0 to 2.65. area from z equal to -3 to 2.65 is nothing but summation of area from -3 to 0 and area from 0 to 2.65. now by the symmetry of normal curve, area from -3 to 0 is nothing but area from 0 to 3. So we have to find out area from 0 to 3 and area from 0 to 2.65. So here probability that -3 lies -3 less than z less than 2.65 equal to area from -3 to 0 plus area from 0 to 2.65. now by the symmetry of normal curve, this area from -3 to 0 is nothing but area from 0 to 3. so we replace this by probability that 0 less than z less than 3 and we keep this as it is. now we are having standard form, so we can use the table. First we look for z equal to 3.0. so for z equal to 3.0, here we have z equal to 3.0. so we have 0.4987, so that we have written here, and now we have to concentrate on 2.65. 2.65 means we have to think in this way, 2.6 plus 0.05. So first we find out 2.6. So this is 2.6, and then we have to go up to 0.05. So this is 0.00, 01, 02, 03, 04 and 05. So the answer is 0.4960, and the summation is 0.9947. So the required area is 0.9947. So in some examinations, instead of cumulative probability tables, you may be given this type of tables which gives you the area under the standard normal curve between z equal to 0 to some specified value of z. So if you are given this type of tables, then also it is easy to calculate probabilities using this type of areas. So this is all about today's session. We have discussed how to use another type of normal table which gives us the area between z equal to 0 to some specified value of z. So in the next lecture we will discuss how we can use normal distribution to approximate binomial distribution. I hope you like this lecture. Thank you very much.